with related rates. Okay, related rates.
Or faster, but also.
Okay, first of all, rates. When we think about rates, we think of rates
Slope.
of change, right? The derivative at a point, like the slope, okay? So this entire lesson is going to involve implicit differentiation. Don't worry, we're going to do some review of that. And we're always going to differentiate with respect to t standing for time. So this is, so if you see d dt, this means
Differential.
this is the derivative of whatever with respect to time. Okay, so we're looking at how something changes over time. Now remember how when we did implicit differentiation, and sometimes you would want to leave it like dy dx and sometimes you do y prime. This is why I tell you it's very important to leave everything is going to be d dt of something. Okay, so we're going to take d dt.
Okay.
All right, Sophia?
So, like, it's dy dt, like, that would be...
Exactly.
Okay.
So this will help and reinforce what we did in implicit differentiation in the last chapter. Okay. So everything's going to have a d something dt in it. Okay? Because notice there's no t here. If I was doing d dt of t squared, it'd just be 2t. Right? So if I did d dt, I get 2t. Okay, but there's no part of, none of these have a t in them. Okay, so that's where the implicit differentiation comes in.
So why would we not just do dx or r?
Okay, what was the lesson named? Related rates. Rates are time,
Oh.
right? Quantity changing, right? So, well, d dt of c is dc dt, right? If I say what's the derivative of y, right? It's just dy dx, right? If I say take d dx of y, that's just dy dx.
Oh.
So C is 1.
Okay.
Is that like multiplication or is it?
It's not c.
No,
C is not.
it's a function.
Oh.
You're taking the derivative of c with respect to time. Well, we don't know what c is, so we're just going to write dc dt.
And there is no.
Okay, and what's going to be the derivative of 2 pi r? Well, 2 pi is just a coefficient, so it's going to be
that's
2
not-
pi
oh.
dr
Take that.
dt. Okay, guys.
Wait,
And-
why do you have?
And that's all we can do. There's nothing else that we could do with this equation. Okay, not until later when we're actually evaluating it. We're just leaving it like this. So this, if we would read this out, this change in, so what do we notice? What's c equals 2 pi r? Circumference. Okay, so the change in circumference with respect to time is equal to 2 pi times the change in the radius with respect to time.
So does this mean anything to us right now, or will we?
No, we're gonna apply it. I'm just baby steps.
Okay.
Okay.
So wait, okay. So the derivative of 2 pi r, wouldn't that just be 2 pi? So then why do you keep the r in this other?
Because it's implicit differentiation. So we're not, if this was d dr of 2 pi r, it would just be 2 pi.
Oh.
But because it's a different letter, right? So here, what's going to happen?
Oh wait, this is gonna be weird.
Okay, on the left side, so we should recognize that's the area for a triangle. I'm purposely giving you formulas
Like
that
trig?
hopefully look a little familiar.
It's
Because
not trig geometry.
geometry, there's a trig down here. Okay, this is a volume of a cylinder. Okay, so on the left side, we just get dA dt. Now, on the right side, if you want to move the 1/2 to the front, you can, it doesn't matter. Or if you want to, this is technically a U times V situation.
Oh.
So maybe I'll make 1/2 B. Oh, bless you, bless you. And I'll make H my V. It doesn't matter. Okay, so U prime. So what's the derivative of 1/2 B? It's going to be 1/2 dB dt. Times H, right? U prime times V plus.
Oh my god.
Oh my god.
Wouldn't this just be plus 1/2 B?
1/2 B. Because.
So it's gonna be 1/2 B.
Yes.
Times dH dt. And again, that's all we're doing with this. We're not, I don't need you to, there's nothing
Wait,
to
why?
simplify.
Why would we do 1/2?
So remember, it's U prime V plus UV prime.
Oh, I thought you were saying we can move the 1/2 to the front though.
Oh, if you did, then you would just have 1/2 times the quantity.
Okay.
It doesn't matter to me.
That makes sense. Because you can take 1/2 out.
Yeah, you could take out a 1/2.
This is all we can. Oh my god.
Okay. All right, next one. V equals pi r squared times the height. But they actually gave us the height is going to be 4. So before I do my derivative, since I know h is 4, I'm going to plug that in. So I'm going to make that 4 pi r squared. And now let's do, so if I already know one of my values, I plug it in first and then do the derivative. Yes.
So when we're doing this, it's not going to be like we're multiplying stuff, like, right? R is going to be the only,
What do you mean?
like, it's not going to be like the product thing, right? Like, we're just going to count 4 as a coefficient.
Right, I wouldn't do product rule.
Okay. So
If
how do
you, if you
Well,
did,
4
how do you
pi
know-
is a constant.
How do you know when?
no, I plugged H in.
Well, like when you're solving for f prime of x or whatever, and you're given x, why would you then do product rule or whatever with x, even though it's like an assigned?
So 4 pi is a coefficient. It's a number. Like I can actually plug it into my calculator. But if it was W times X or whatever, you know what I mean? Like if it was a letter times a letter. See how this is, we have 2 different letters?
Yeah.
So I have to,
But like if you have like an equation where you have x in it, and then you say like find the derivative of it
with
when
respect to what?
When x, like f prime of x whatever, when x equals
Yeah.
4, you wouldn't make
Right, because you're
4
trying to
coefficient.
find the equation for the tangent line and then plug in 4. This is a different scenario. This is saying my volume, my height is always going to be 4, but my radius is changing. Okay, so here we get dv dt equals, that's going to be 8 pi,
dr dt.
8 pi r dr dt.
Wait. Oh.
You got it.
Just remember the
Why would it be 8 pi r?
Because it's 2 pi.
because it's
2
square power rule.
Yeah, I know, but
R squared.
it's r squared, but then you get 8 pi r. That's the derivative. But then why is it dr?
Because that's our implicit
Derivative.
But what if
differentiation.
that? Oh, because you. Oh.
Do idea.
Okay, all right, Sophia.
If it had been 4 pi r cubed, would you get 12 pi r dr squared dt?
Say that, I'm sorry, one more time.
If it had been 4 pi r cubed, would you get 12 pi
Pi
r
r squared
squared
dr dt.
Well, yeah, because it'd be 8 pi r squared and then dr squared dt.
No,
or
no,
is it
just dr
Just
dt.
dr dt. Okay.
Okay, next one we get dy dt on the left side. On the right side, so secant, what's it? Secant squared of theta d theta dt.
Oh, because you can also do secant squared of x if it was
What isn't it
tan
secant
x.
squared of theta tan theta? Oh no, that.
No,
never
that
mind.
would be
That's
if we,
secant.
Yeah, that's secant.
Yeah.
okay. Good. All right.
Do we? I'm noticing that I just skipped this step and I just went straight into dy over dt equals.
That's okay.
I don't have to go and put
Well,
like each
there's
side
gonna
in
be
front.
a situation where we have to do it on both sides. If it's something like this, you can go right to dv/dt. Here, let's look at some more, before we get to the actual application, let's do another example. Let's say we have a right circular cone. Here's the volume, 1/3 pi r squared times the height. How is dv/dt related to dh/dt if r is constant? Okay, so I want to do d dt of both sides, but I want to treat r as a constant. That means 1/3 pi r squared is one whole coefficient. Right? So this whole thing here is one big coefficient. We don't know what r is. It could be 10, it could be 2, it could be 3.7. But whatever it is, it's constant. So what's dv/dt going to be?
1/3 pi r
1/3 pi r squared
squared.
dh/dt.
If we put h prime, that's wrong because
That's
h
wrong,
prime
because h
is an
prime.
assumption of.
So
so
this is where it's a
okay.
little different in implicit differentiation. I specifically want you to put it with dt because it could have a different meaning. This is all related rates, remember? Related rates. Everything's going to have a dt in it. Yeah.
Why wouldn't it then become
Oh.
like
It's supposed to be an h.
2/6 pi r dh/dt?
Because this is all one coefficient. I don't want to do the derivative of this because what's the derivative of 4x? It's just 4. I don't want to change the value of this.
Okay.
Okay. This next one was supposed to say, what do we do if h is constant?
Wait, that's the answer?
Yeah, that's it.
You can't h all.
Okay, I'm gonna put 1/3 pi h r squared. Oops, sorry, forgot to put my ddt on that side. This time we want to treat h.
So can we rearrange
So,
it?
that's why I rearranged it. So I'm gonna put 1/3 pi h in front. So now that's my coefficient. Right, so if that's my coefficient here, what would dv/dt equal? Okay, all of this is a coefficient, so really I'm just doing the derivative of r squared,
So
which will be 2r dr dt, right?
So
So
2/3
2/3
r squared h, or no, 2 pi h r times dr dx.
dt, yes.
Oh, sorry.
It's okay.
In the habit of
All good.
the other one.
Does that make sense? Because if all of this is my coefficient, it's really just doing the derivative of r squared, which is 2r dr dt. So I just made that a 2/3. Okay, one more and then we'll actually do some real problems. Yeah, Sophia.
If the coefficients, since it's two coefficients, when you have to do product rule, or like,
You don't have to do the product rule with a coefficient.
right, cool.
Okay, now, next one, we are going to do the product rule. Why? Neither of them are constant. So I have, are you okay if I just write dv/dt this time? Okay, so I want to do and actually, just to make it a little easier, I'm going to put 1/3 pi in front, and then I'm going to put d dt of r squared times h. So I'm not putting anything out in front for this one because, or I'm not putting r or h out in front because both of them are changing. But the 1/3 pi, you can keep it inside or out. It doesn't matter. Now we have a u times v situation. Right? This is going to be our u. This is our v. So I'm gonna leave 1/3 pi. Okay, so.
Oh, this one's weird.
Okay, so derivative of u, so that's gonna be 2r dr dt. Notice every single time it's gonna have that variable dr dt, right? So 2r dr dt plus, oh, sorry, times h. Plus, now we're gonna leave the r squared.
DHDT.
Yeah, dh, because it would just be 1 dh dt. Perfect, we'll just leave it like that.
So these answers are just gonna be a bit long this chapter.
Okay, so I just wanted to practice taking DDT of both sides. On the next page, we're actually going to plug numbers in and get an actual answer.
Okay. And then if I reorganize that answer to be 2RH times
Oh,
DRT.
that's fine.
Okay, I'm not
That's
sure
totally
if it
fine.
has to be next to the.
It doesn't matter.
Is it fine if I multiplied that out? Like I didn't
Sure.
take out the one.
Yeah, you don't, yeah, it doesn't matter. Okay,
Oh wow, but these are really okay.
okay, so now we're gonna do some applications.
Sir?
Oh, those? I didn't look at those.
Okay, the base of a right triangle is increasing at the rate of 3 centimeters per second, while the height is decreasing at the rate of 2 centimeters per second.
Can we make just like a.
Okay, let's draw a picture.
Yay, okay.
Oh yeah, that is pretty bad.
Okay, it's a right triangle.
Mm.
This is pretty good.
Okay. All right. Now, the base, so here's B is at the bottom. And it's increasing, so it's getting bigger. It's going that direction. It says at the rate of 3 centimeters per second. That's a related rate. So that is dB dt equals 3 centimeters per second.
Oh, because velocity is derivative.
Could you roll it back up a little bit?
Sure. Is that further?
Yeah, yes.
More?
Yeah, a little bit.
Which one? B?
Oh yeah, I just forgot to put the HR thing. I got it.
Oh, you got it now? Okay. Okay. Now, what else is happening? The height is decreasing at 2 centimeters per second. So here's my height, and it's going, so the base is getting bigger. So kind of picture this triangle where the height's going downward, base is getting bigger. It's decreasing at 2 centimeters per second.
Skinnier.
So I'm going to say dH dt is negative 2 centimeters per second. So if it says decreasing, that implies a negative rate.
I just realized where the area of the triangle is 1/2 base on side. Because it's half of a rectangle. A
It is.
rectangle's area is the
Yes.
Yeah, you never.
No. Did they never explain that to you? No.
You needed that explained.
Okay, when b equals
Okay,
4,
but they went over it in.
when b equals 4 and h equals 3, find each rate of change. So the first one says, I want to find the rate of change in the area. Okay, so first thing we want to do is just write, what's the area formula? 1/2 base times height. Now I'm not plugging anything in because I don't have anything constant. Is the base changing? Yeah. Is the height changing? Yeah. And so that means the area is going to change. So I'm going to do d dt of both sides. So we're going to go d dt of A. Are you okay if I put the 1/2 out in front?
It's better.
Yeah, I agree.
I like it more though. Because you can multiply it out after, but it makes everything simpler.
I agree. Okay, on the left side, I have dA dt equals 1/2. Okay, we got a u times v situation because they're both changing. Nothing is constant. So it's going to be derivative of b. So that's just going to be dB dt. Good, times h plus b times dH dt. Okay. Do I know what dB dt is?
Yes.
Yes, it's 3. Do I know what h is?
Yes.
3. Do I know b? 4. Do I know dH dt? Negative 2. So we can plug everything in.
Wait, we know base and height?
We know-
Oh!
Right?
Oh my god.
So we have 3 times 3 plus 4 times negative 2 in parentheses. So that will be 9 minus 8,
So it's
1/2. So this is 1/2, and it's going to be square centimeters per second, because that's the change in area with respect to time, right? And we use square.
Is that like the ratio basically?
It's not the ratio. So basically what's happening, you have this triangle, right? And at different points in time, now, maybe when the base is 5 and the height is something different, it could be a different rate. So as these are changing, the actual area of the whole thing is changing. If you kind of picture that as it's expanding.
Oh, this is when specifically while it's shrinking,
Yes.
it's growing.
Instantaneous.
So what's that mean? So
Yeah,
when this is 4 and when this is 3, the area is only increasing at 1/2 square centimeters per second. Okay, so it's not growing as fast. What if it came out to like 10? That's a much bigger change in the area.
That wouldn't happen with one side decreasing.
Yeah. Okay, so again, what's this? The section's called related rates. We're trying to see how the rates are related to each other. So next we want to look at, what about the hypotenuse? So,
A squared plus b squared equals c squared.
okay, so do we want to use, it doesn't matter. Do you want to use,
Not h squared.
do we want to use H, B, and C?
Yeah.
Yeah.
Doesn't matter. It's the same triangle, it's the same rates of change, but how are H, B, and C related? H squared plus B squared equals C squared. So remember how we started out the last problem? I said, what's the area formula? Okay, so we want to kind of take it step by step, come up with the formula.
But should we isolate c?
Doesn't, I
So
wouldn't
it's
bother.
isolated.
I would
What's
just
the
go,
answer 5? Because don't you just do base 10?
No, because that's only when it's 4 and 3, but this is like changing.
Should we do the square root one?
nope, nope.
That's
Just go
the-
right to d dt of both sides.
Oh, and this is gonna have like different derivatives of like 2 times.
Yeah.
Okay.
Okay, this is just, we're adding.
This is basic.
Okay, so what's the derivative of h squared? It's going to be 2h dh dt. What's the derivative of b squared? 2b
2b.
db dt,
You
I
what
know.
I'm gonna say.
A lot of letters in here.
It's like
And then
a
2c
or no, it's
dc dt.
If we accidentally like switch a B and a D, would you like understand that it's
Yeah, that's fine. Okay, I have 2 everywhere, so I can just, are you okay if I just cancel all the 2's? Okay, so now we're going to see how does the hypotenuse change? So do we, is C, is the hypotenuse getting bigger or is it getting smaller? Well, what's H? 3. We're using the same values, so 3 dH dt, which was negative 2, plus B, which is 4, times 3, equals, C and dC dt.
Wait, but we can find C by using this equation.
So, if the base is 4 and the height is 3, it's a 3, 4,
It's
So
5.
it's 6.
5 triangle.
What?
I don't
Right?
remember these triangles. Am I supposed to?
If you have a right triangle, it's a Pythagorean triple, right? So when this is 4, this is 3, this is 5. Could you also just do Pythagorean theorem?
Yes.
So I have 5. dC dt is what I'm looking for.
So it's
Okay.
Divide it all by
6 divided by 5.
So this is negative 6
Oh, yeah.
So
plus
it's
12,
6.
6 over, so 6
5.
fifths. So dC,
Sorry.
and this is centimeters per second because it's the length of the hypotenuse. It's not squared. Right. So
What are you guys?
How did you get?
How'd you get 6/5?
well, this is 6, and then divide by 5. Sorry,
Oh,
I just-
oh,
we're running out of space, so I just.
But
I
that's
do that.
okay,
It's
but
AP
okay.
Calc. You can do it.
I always just move the answer to the middle. That way it saves space and like you can see where the answer.
I know, sometimes I'm torn between like saving trees and like making sure you guys have enough space to write. It's a real thing that we
For
struggle
the
with in the math
multiple
department.
choice ones, there's never enough space.
I
But it's okay.
Okay, are we okay? So that means that the hypotenuse is getting bigger at 6/5 centimeters per second at that instant. Okay, last one, the perimeter.
That'd
Okay,
be
well, what's
base
perimeter?
times height times c.
No, what's
Or
perimeter?
plus,
Just
plus,
the
plus,
three. So it's just gonna be h plus b plus c. And we just wanna do the derivative of that.
Oh, well,
Oh, come on, it's just, literally this is just gonna be it. It's gonna be dp dt equals dh dt plus db dt plus dc dt. Look at that. Look at that beautiful equation with 0 numbers.
this is so horrible.
Do
This
you-
is the part of math that they were warning us about.
DPDT
but this is the
equals
beauty.
DHT
No,
equals
actually
DHT
get to
equals
apply it.
DCT.
Okay, so we're looking for the change in the perimeter with
Yeah,
respect to
numbers
time.
are really nice.
Okay.
Can we bring them back?
Maybe this isn't that bad. This is like
It's
This-
so funny because you started off with like
Guys,
small numbers. and
Literally, this is
Well,
like the
6/5.
simplest numbers that we probably had to work with. What was DHDT?
It's 11 fifths.
Wait, no.
-2.
-2. dBdt is 3. And we just solved for dCdt.
So it's 11 over.
Yeah, 11 over 5 centimeters per
This is
second.
gonna be the simplest it's gonna be because we're just plugging in numbers.
Yeah.
But also, what happened to when it's just 2 plus 2 equals?
it's calculus.
It's funny because like the harder your math gets, the less numbers.
I don't want to hear it.
The difference.
I don't wanna hear it.
Okay, last one on this page. So
Now
let's say the
something
angle
else.
theta is the angle where the base and the hypotenuse intersect. So that's going to be here. Okay,
I remember it being so fast.
we can use. What's wrong?
The fives were
Doesn't the
easy.
angle never change?
Well, no. When this goes down, then this is
It gets
going.
skinnier.
Yeah,
But,
and this
oh,
is
it's
going
not
down.
like it's not scaling. It's just they're all
Yeah, because
getting.
this is getting bigger when this is going down, so it's getting skinnier.
Oh! I thought
Wait,
it was like
so
all
theta also
increasing.
changes.
Theta's also changing. So how can I relate
Yo.
using trigonometry?
Oh,
I can do
Inverse sine.
I could do sine of theta
Inverse
equals
tangent.
h over c. I could do
well, let's
cosine
do
of
h
theta
over b
equals
because
b
those
Yeah,
over
what
are
if you do
the
inverse
values
tan?
we know.
or tangent. They will all work. We'll get the same. I'm gonna do tangent.
Well, because no,
if
but
you're
also
wrong,
it's
then if you're
because
wrong.
if you're
Wait,
wrong,
why do we
then
need-
you
oh,
would
wouldn't it be
get
inverse
totally did not
tangent?
see
These
that.
numbers.
Because you're trying to find that. Wouldn't it be inverse tangent?
Well, no. We don't want. If we knew h and b, we could do inverse tangent. But what did we do in every single situation? What did we do?
Different.
We started with our formula.
Implicit difference.
And then we did ddt of both sides. So I want you to do that again here. So d dt. Oops, I don't know why I wrote tangent. That's supposed to be ddt.
How much worse does this get in college? Just
So much
you know,
worse, so much worse.
since we're at this point and all,
So
how much
Okay,
worse?
let's not talk. Let's keep
So
going.
much worse. Have you seen?
All right,
this
what's the
haircut?
derivative of tangent?
Secant.
Secant squared.
Wait, but wouldn't it be times d theta?
Yeah, of course.
Yeah,
d
d theta
d theta.
dt.
And then whoa, how would you do that?
Stop.
No,
Okay.
1/2.
Just
Okay.
Can we do like h times b and then -1?
You can, but I'm just gonna do quotient rule because I'll show you when we plug in all the numbers. It's easy. So so low d high. So the bottom b, d high. So dh dt. Take high times d low. So cross the line, square the low.
Oh, and b is like an
Now,
easy number.
what are we solving for? We're trying to solve for d theta dt. Okay, so take for a second. What's secant squared of theta? So let's go back to the triangle that we were provided. here's theta.
Oh.
What's secant? Secant would be hypotenuse over,
Well, cosine. is-
cosine would be 4
Well,
over
it's
5.
cosine,
So then
so
it's
it's
5 over 4 squared.
Oh, we
5
can
over
square
4,
literal
so
5 over 4.
25 over 16.
So it's going to be 25 over 16.
Theta. Fine.
Okay.
Oh wait, do we have to put the theta?
No, because to the entire.
Yeah.
It's so nice.
Wait, how do you get 5 over 4?
The triangle.
Or the 25 over 16?
Remember the-
Just 1 over cosine.
No, no.
Are you enjoying this lesson?
These are the measurements of
It's
the
actually
triangle.
not bad. And then can we just plug in?
Just start plugging all the numbers in. So B is 4. dH dt is -2. Minus H is 3 times 3 all over B squared, which was 4 squared, so that's 16. Which actually works out nicely, because we can pretty much cancel out the 16s.
So it's -17 over 25.
-17 over 25. And the units are kind of weird. It's radians per second. Okay. Today, just a heads up, we'll probably not gonna finish the lesson, but that's fine. We usually don't, which is why we have an extra
that's
repeat.
not
Why is
bad.
it radians per second instead of degrees?
Oh, no, we always work with radians in calc. Always.
Yo.
Why are there so many
options?
I didn't realize that this was part of our lesson. I thought this was part of tomorrow's.
We don't
We don't have tomorrow.
No, because we
Right.
don't have school on Thursday.
Okay, so we don't need tomorrow?
Oh my gosh.
It's not till next Tuesday.
Actually,
What's not due until next Tuesday? Our homework?
We don't have
No, the quiz. Okay,
sir.
all right. Now,
We don't have
just like
tomorrow?
when we were doing
No, we
optimization,
do.
just like when we do optimization, the hardest part is coming up with the equation, and then we get to do our derivative part, and then you just plug in, okay? So sometimes, right, we drew a picture, right? Obviously, you have to figure out, okay,
Wait, what is it? What's optimization?
Oh,
Just
girl.
look at your.
You were asking it too.
okay, Madison is gonna have a very hard time watching this video, so,
Oh my god, Madison.
Oh, Madison, we
Hi.
love you, Madison.
okay.
Sorry, Madison.
I know exactly what she's going to say. Okay, so we're going to identify the variables. So remember on the last page, while I was reading this, I was identifying what were my rates that I was given, okay? So that's an important piece. We're going to write, this is the big part, write an equation relating the variable. Okay, so if it's perimeter, you write P equals this plus this plus this, right? 1/2 base times height. Differentiate both sides. Right, so this is writing an equation, both sides implicitly with respect to time. Substitute any of the quantities and then interpret the solution. So sometimes we might have to write, not like full-on sentences, but I might ask you to interpret what does that mean in the context of the problem. Okay.
So can it be like 2 words, or would it be?
It could be, like in the last one, we just had to make sure we included the units because it was implied. Okay, we got
Yes, I do talk to Madison.
I don't know who's friends with who.
Okay, it looks like it kept going.
Yeah.
Okay, this is d theta dt.
Wait, how do we?
Okay, let's, it's radians per, I literally just change.
No. I didn't understand what we were doing, but I got it.
Okay, so let's kind of picture this. I'm not an artist, but let's say here's our hot air balloon with our, right, our basket.
That is gorgeous.
Was that nice? Okay, so here's our picture. So it said straight up, so here's my height of the balloon. And it says it's tracked by a rangefinder that's 500 feet from the liftoff point. So which is going to be 500 feet? The hypotenuse or the bottom? Bottom. Here's our rangefinder down here. Here's our person.
Oh, that's my bad.
Well, it wouldn't be a hypotenuse, it would just be a side. No? Like a leg, aren't they?
What's wrong? Okay, now there's a reason I actually labeled that 500 feet. This is a constant. That's not changing. Okay, so the balloon's going straight up, the rangefinder's over here. This is not changing, but the height is changing. We want to know, so we know what theta is changing at. So here's theta. We want to see how fast is the balloon rising. That's looking for a DHDT. How fast is it rising? That's our DHDT that we're looking for. Okay, so this is kind of like the very last one on the other page. What formula do we want to use? Tangent of theta equals h over 500. So tangent.
Can we? Oh. Well, wouldn't we be able to multiply 500 by tangent before we start anything, so we don't have to do quotient?
Sure. Well, I wouldn't do quotient anyway. I would make that 1/500th times h.
Don't we know theta
But
right
okay, I mean, it doesn't matter.
now? Do we know theta right now? Because it says the elevation angle.
Okay, but it's
is
changing. The theta is changing. So as that balloon goes up, the theta is getting bigger and bigger. The only thing that's staying constant is this measurement. We'll plug that in after we do the derivative. Okay, so we can go to d dt of both sides. What's that going to give us on the left side? 500 secant squared theta d theta dt
And we're looking for DHDT.
dh dt.
Okay, so
Okay.
we can't solve this all the way. Like, we're stuck with that, right?
Oh, no, we can definitely solve this because there's something else we were given.
Yes, you can.
At the moment, the rangefinder's elevation angle is pi over 4. It's increasing at 0.14 radians per minute.
Oh,
Okay.
so
So
we already wrote it down.
can we figure out, so what would secant squared of pi over 4 be? Okay, so let's think cosine of pi over 4 is 1 over root 2. Flip it, so it's root 2. Square it, it's 2.
Secant squared theta of pi over 4.
We know d theta dt is 0.14.
So it's 1,000 times.
So 1,000 times 0.14. Come on, we could do it.
14.
140.
No, that was not it.
140.
I missed a 0. That's my bad.
So the balloon is rising at 140 feet per minute. I'll just,
Wow. Oh wait, no, that's like a foot per second. That's fast. Yeah.
I mean, some of them rise pretty quickly.
Yeah, that's good. That's like that acceleration would be high
Well,
up there.
Don't worry, we don't have to do acceleration. It's just,
Well, we
First-
already doubled the yeah.
well, not with these.
Oh, wait, are we not gonna do all the homework until you have done with the last? Or if we don't finish?
No.
I would like to do,
A foot a second for a hot air balloon.
let's see if we could do this one.
But then for the homework, we'll have everything.
A right angled intersection.
We won't have gotten to all the different examples, but we got to the bottom line is we got to all the skill set. It's just, I didn't get a chance to go through all the examples. So what we'll do is, you're gonna try the homework, do as much as you can, and then tomorrow we'll finish the notes and I'll give the practice quiz. Okay, Sophia, and then we really are short on time.
Sorry,
What was it?
I figured it out.
Okay, all right, I'm gonna draw a picture for this next one. So, okay, we got a police cruiser approaching a right angle intersection from the north. Okay, so here's our, so it's going this way. So here's our police. So it's coming from the north. It's chasing a speeding car that's moving east. So
It's coming from the west.
it's like that. So here's my speeding car here. And I'm not drawing a picture of a car.
It's just a rectangle.
Wait, Miss Gabriel,
Rectangle with
wouldn't Wouldn't the speeding car be to the left? Because it's going east.
Oh, did I draw it backwards? It doesn't, okay, fine.
Well, no, east is that way.
It's moving east from the west.
So then it's going that way.
Yeah.
I was
We're just
They're gonna,
Oh my gosh, I was right. Come on, Z.
It's moving east.
What are you
This is
thinking,
east, that's
Z?
west.
It's moving east, Z.
Okay.
What are you talking about?
Oh my.
Z is
Yeah,
like
no, I know,
out
but
of the
it's
world right now.
it's moving east, which means it's coming from the west.
What are you
Okay.
talking about?
Stop, just stop.
They're not talking about Z.
Okay,
God.
see that, we literally just wasted 30 seconds on that. Now, there's my right angle.
Hey, Z is like not.
My police car is going this way, the
Oh, I
speeding
didn't
car
read
is
the
going this
proposal.
way.
You're so stupid. God.
So, when the cruiser is 0.6 miles to the north and the car is 0.8 miles to the east, the police determine with radar that the distance between them is increasing at 20 miles per hour. So this is going to be, I'll call it Z because I just called these. So it's increasing at 20 miles per hour. If the cruiser's moving at 60 miles per hour, so dy dt, we want to find how fast the speeding car is going. Now, is anything staying constant? No,
yes.
everything's
Yeah,
changing,
well,
right? This is
technically,
getting,
that guy's.
and I'm not only going to call it 60, I'm going to call that a negative
Wait, why is that
going
dy
down.
dt?
because it's going down.
Isn't dy dt the accelerator? No,
No
it's the velocity.
velocity.
Okay, how can I relate X, Y, and Z?
A squared plus
Good. It's actually pretty easy from here because we already did one like this. So it's going to be 2x dx dt plus 2y dy dt plus equals 2z dz dt. I'm not going to write the twos if that's okay. And at this point, it's really easy because we just plug all our values in. The cruiser's 0.6 miles, so that's y. The car is 0.8 miles, so that's x.
Oh, that's like the distance.
Yeah. 0.6.
Well, we have to figure out the distance between the two first.
Right, but 0.8 and 0.6 would make this a mile. When x equals 0.8, y equals 0.6, using Pythagorean theorem, we get z is 1.
Because then you have to do, then it's just equals 20.
Yeah.
So then.
So we get all this just to save some time, right? We can solve for dx dt with some simple algebra, and we get 70, what? 70 miles per hour. What happened?
I got 10 over 0.8.
Hmm.
I got 10 over 0.8 too.
Oh.
So I did my
dy
20.
dt is 60 miles an hour.
Did you put negative?
No.
Because it's
It's supposed
a
to be negative
decreasing.
60?
Yeah, because it's a decreasing value, right? This distance is getting smaller.
This is.
How do we know that?
Okay, listen, I see you guys, after bonus tomorrow? Try to get a few of them done from the homework, and we will do this last page and a half, and then we'll spend time working on homework, okay?